Hi there, my name is Max, and in this video I'm going to explain how to solve the question about the hot water flowing through your pipeline. At the left side I've drawn a sink and your pipeline where we have X in this direction and water is flowing that way. What we are going to use is a microbalance, since again we are interested in making a temperature profile. I'm taking a slice from x to x plus dx. So this distance is equal to dx. And water is flowing in and the same water is flowing out. But there may be temperature differences due to the fact that heat is flowing out via this side of the pipe. Last time we used the mass balance. This time I'm going to use a heat balance to solve this. And I'm taking the heat balance over this piece dx. So it's in minus out plus production. And since we are steady state, we assume this because we're looking at longer times. The inflow is the mass inflow times the temperature, the internal energy at x minus the outflow times the internal energy at dx, x plus dx, minus sign here since heat's flowing out, vq. Now I can rewrite this. I can do this and I may use Newton's law of cooling, which is H times A times the difference in temperature. Now I can sum this up and use minus sign again, the differential form here, and I can use P times the diameter times dx for the area, since it is a pipe. And if I rewrite this again to a differential form, so I take the du and the x at this side, and I take this at that side, and for delta t I'm using the t at the spot x minus the t of the environment, and this is assumed to be constant, and we get this equation in which the difference in internal energy is also the difference in Cp times T, in which Cp is assumed constant in temperature. So we can say this, and we can rewrite it. So T minus T environment on one side, and the other side is minus this, and we can integrate this by separation of variables. One note, I'm just going to call this set alpha, which will make it easier to write down since it won't change anymore. So the solution of this differential equation is this. So minus alpha times x plus a constant, again we have the constant, and we've done this a numerous times actually. You should be able to do this, and the initial condition, which I am going to say T0, T at T0 is T0, and we'll just fill it in later on, but this is the easiest way, which gives us at T0 x is 0, so E becomes 1, and we are left with T0 minus T environment is K2. So now we know our constant. I can fill this in and fill in all the variables and rewrite it to just find the t expression, and we find this. And fill in alpha for that, which are just some variables. Oh, I see, I forgot the CP here, right? Since CP was over here. And this is our final equation, so the temperature profile over the pipe. And you are asked to draw a correct graph, and as you can see, if at x is 0, then this becomes 1, and this is what we are left with. So then only t is 0. So we have to start right here. And at x is very large, then the whole part of E will become 0, and then 0 times something is still 0, so we'll find T environment, so we have to get here at the end, or close to that, since the farther we're going away, the more close the temperature will be to the environment, and the relation is a negative exponential, so I will draw this. And then the last question was to fill in some numbers and find the correct temperature. Well, if you have found this equation, you can just fill in all the numbers, all are known except for the x, and you should find that the answer is 76 meters. I thank you for watching, and if you have any questions, please feel free to ask them on the forum.